Okay, today's video should be pretty quick because we've already sort of done all this stuff. Now it's just putting it all together and finding ways that we can connect data in four forms. What this is known as also is called multiple representation. So if you remember the matching activity that we had done at the beginning of this unit, we had our four forms, of course, is the table, and we're going to make a table right now. We have a table, we have a graph that corresponds to the table, and then we have an equation, and then we have, our story problem, our scenario we'll put here. Okay, so if you remember this activity, they were related. The situations all had something that sounded kind of the same, but maybe a slight difference in the direction of the change, or the numbers were flip-flopped. So if you look at this one, handyman charges $60 per appointment plus an additional $20 per hour that he works. That means that he is not proportional. When x is 0, he's got a $60 flat rate, and then if you look at the rate of change for every hour that he works, it's going up by 20. So this in equation form means you have an intercept of 60, and then it's increasing by 20 per every x, which is your hours. So you're looking for a line that has an intercept at 60, and it's increasing. So again, just test it to be sure. At hour 1, 80, that corresponds to our table. At hour 2, that's 100, that corresponds. So this would be the scenario, totally matched up in all four forms. Not to be confused with this one, which looks the same. If you compare these tables, they both start at 0, 60, but this one is going up by 20 and this one's going down by 20. So how is that going to change your equation? Well, now the coefficient is going to be a negative 20, but again, it's starting at 60. So we are looking for a graph that starts at the same place, but it's decreasing. And then we're starting at 60, and now you are using up 20 every single time. So the situation that was related to the handyman would be this Amazon gift card. Okay? So this is what you're going to be asked to do in the next classwork. Some things that might help you is, again, here's this table that we are going to look at. So from each of the four forms, we are going to see if we can't identify things that will help us with the slope and the y-intercept. So when I say slope and I say y-intercept, really slope refers to the steepness on a graph, on a line. So here we have to identify what is the slope, and we also have to identify where the line hits the y-axis, which is known as the y-intercept. So on a graph, your slope and the y-intercept are the ones that we're really, really concerned about. Well, on the table, if I'm talking about a table, I don't really say necessarily slope, I say something else, and what we've told y'all way back in the beginning, that this is the rate of change, or ROC, if you will. So rate of change is how the increase of y for every increase in x. So then you think, well, where's the y-intercept found in tabular form? Well, when x is 0. So when x is equal to 0, what is the corresponding y value? So again, this is kind of like a cheat sheet that you're creating for yourself. So then we're thinking, all right, let's go to the equation. And so in the equation, where's the slope found? And the equation, of course, is always in slope-intercept form, which is y equals mx plus b. So where's the slope? Well, it's the m, and what do we call the thing that I multiply the variable by? The coefficient. Yes, so it's the coefficient of x. And then what do we call the other piece of this, the thing that I add or subtract? Well, that's the constant. Yeah. And in standard form, we know that the constant should be at the end. Now when we have stories and we have real-world context, you have to think the story is going to be your rate. So the keywords for this is per, it's monthly, whatever's happening with the x, it's for one of those. And then the y-intercept, well, what is your starting value? So in the beginning, was he charging a flat fee? In the beginning, were you in debt by $40? Okay. So when you are starting, again, when you're starting with the table and you're constructing it, really you should start when x is 0. Not at 1, when x is 0, because then that gives us our y-intercept value. Okay, so then you can use this little cheat sheet to start with any given part of this and then construct the others. So for instance, if we had started with the equation maybe y equals 5x plus 12. Last quiz, y'all were asked to write a story problem based on this, and really the only numbers that you got to use are 5 and 12, and you have to use them appropriately. So you would say something very general like Sally starts with $12 in her account, and then that addresses the y-intercept, the constant part of it. And then how is the rate changing? Well, it's changing per every one of x. So you have to figure out what x is. So I've defined sort of y to be money in account. And then what is that based on? I mean, let's say x is number of days passed. So maybe she's doing some tutoring after school and she's getting paid $5 a day. So if Sally starts with $12 in her account, then she adds $5 per day. And in general, if I've defined x to be the number of days passed and y to be the money in her account, we can ask a very general question. So she starts with 12 in her account, then she adds $5 per day. We can say something like, write an equation for how much money in account after x days. X days. Okay? So very general question, because I can ask about any particular day or any particular amount. So then how would the table for this look? Well, if this is x and this is y and this is a story problem, we'll go ahead and define these further. So x is the days, and what depends on that, the money does. So we start at 0, and in the beginning she had $12. Then at day 1, it's increasing by 5. My rate of change is 5, so that means she has $17. And at day 2, my money increases by 5, so 17 plus 5 is 22. And we can keep going and going and going. So then my graph, I'm just going to sketch this for you so you can kind of match it up, would be like this. So it is a big quadrant 1, because I can't have negative days or negative money if she's just increasing. And we have an intercept up at 12, so we have a point like this. And then at day 1, it's up at 1. So I can follow slope, which says go up 5 and over 1. And then you have a point here, which takes us to, that should be 17. And then at day 2, I can do it again, up 5 and then over 1 would take us to the coordinate pair 2, 22, and it would look like this. Right? So you match them up. We can ask you to start with the table and then generate the graph and then generate the equation and then come up with the story. And the story, just really keep it simple. Address your starting value and then address how it's changing.